Hi, welcome to Provoke Your Physics channel. So now we are going to see the Ohm's law, that is the continuity of the previous video. Actually, in the previous video, I discussed about the drift velocity elaborately. Okay, so from that we came to know that the net velocity of an electron in a conductor is zero when it is exposed, when it is not exposed into an electric field. Okay, but now we are going to discuss what may happen when it is exposed into an electric field. Okay, so from that we are going to derive the Ohm's law. That is, okay, especially I told you there are two types of Ohm's law. One is microscopic form and another one is macroscopic form. Okay, right. Let us discuss a conductor. So there is a conductor. For our convenience, I am going to take it has a length L. Okay, and so it has an area A. Area A. Okay, so now it is connected between an electric field. Okay, between the battery. Okay, on two terminals of the battery. Okay, now when the electrons are enter into it, of course there will be a drift velocity is going to occur. Okay, now for that, okay, I am going to consider the small portion. Okay, that is dx in which go small portion dx. Okay, so the dx will be the small portion or the small distance, okay, have been covered with the electron, okay, by the time of dt. Okay, I know that the drift velocity vd will be equal to dx divided by dt. Okay, we know that dx divided by dt. Okay, suppose if I want to know the displacement, I can simply write dx is equal to vd into dt. Alright, now I would like to measure what would be the volume of this portion. Volume of this portion. Okay, so we know that the volume is nothing but area times the length. Okay, area times the length. So the volume will be equal to area times length. What is the length? Length here is dx. Dx. Okay, so instead of dx, I may have written vd into dt. Okay, that is a into vd into dt. What is this? This is the volume. Okay, actually why I am doing all those things? Because I just want to know the number density. Actually, what is the number density? Total number of electrons per volume. Okay, so usually this denoted with the letter small n. This will be equal to capital N divided by V. Okay, now if I want to know the value of capital N, good. Okay, so capital N will be equal to n times of V. Okay, now I am going to substitute the value of, okay, n, okay, and V, okay, here. So n, that is a number density. Okay, suppose if I want to know the value of n, okay, I am just writing capital N will be equal to, okay, n into, instead of V, I am going to write a into, okay, vd into dt. A into vd into dt. Okay, now I have got the value of n. What is that? That is the total number of electron which is available between the length dx. Between the length dx. Right. Now I am going to find what is the total charge will be available here. We have a very important formula, that is Q is equal to n times of E, where n is the number of electrons and E is a charge of an electron. Okay, now if I want to know the value of Q, okay, that is Q will be equal to n into A into Vd into dt. Okay, that is Q. Okay, actually what is my aim? To measure the current. Okay, that the current I is equal to, I know that dq divided by dt. So if when there is a small time dt means the charge will be dq. Okay, so now dq is equal to this one. So I can just write n into a into vd into dt, okay, into e, okay, divided by dt. Okay, right. See here, n is the total number of electron which is equal to number density times volume. Volume is equal to a into vd into dt. Okay, so dq is equal to n times of E. Okay, according to the formula, Q is equal to Ne. N is the number of electrons and E is the charge of an electron. Okay, when I substitute, dq will be equal to n into a into vd into dt times E. times E. Okay, so I is equal to dq by dt. What is I? That is nothing but the current. Okay, that is a rate of flow of charge, dq by dt. Okay, now I can cancel dt on both sides. On that is the denominator and numerator. So I will get I is equal to N A E V D. See, that is a very important relation. What is that? That is the relation between current and the drift velocity. See, current and drift velocity is directly proportional. So what is its meaning? When the current increases, drift velocity is also increases. Right. Okay. Actually, what we are discussing now, we are discussing the microscopic forms of Ohm's law. But we have got the relation between current and drift velocity. Okay. Now, I already told you in the previous video, Vd, that is drift velocity, is equal to E tau divided by M. Okay. Now, I am going to substitute the value of Vd here. So, I will get I will be equal to Na, okay, E into, instead of Vd, E tau divided by M. Okay. Now I am going to introduce another one term that is called current density. Current density is nothing but current flows per unit area. So I by A is equal to J. Okay. So here when I take this A here, I may get I by A. This is equal to J. What are the remaining term? E into E squared, that is N E squared E tau divided by M. Tau divided by M. Okay. So I have got J is equal to N E squared tau divided by M into E. Now look at the terms which is available in this equation. N, that is the number density of an electron. E squared, that is the charge of an electron. Tau, that is a collision time. Actually, the collision time is constant for a particular metal and also the element. And M is the mass of an electron. So these are all constant. Okay. Now, instead of this constant, we are going to put the value, this J is equal to sigma times E. Okay. What is this sigma? Sigma is nothing but conductivity of a conductor. Conductivity. Conductivity means it is a reciprocal of resistivity. Okay. So this is actually called microscopic forms of Ohm's law. Thank you.